Sketch reciprocal of linear function. Well, this exercise seems to be very simple and basic. It is basic. And here we have two extremely good examples. Both are lines. Do you see that? And I want you to sketch reciprocal of these lines. These lines represent linear function, right? Now, most of the time students have this thing in their mind that reciprocal of a linear function will look like 1 over x function, right? Because that's how it is. It is kind of transformation of 1 over x. You will soon realize that there is an exception to that rule. Well, most of the time it is like this, but not always. So here, let's go and do it. First, this is a line, and when you have to draw a reciprocal of a function, then first thing you have to look for is x-intercepts. So for this line, we have x-intercept here at 1. So 1 over 0, x-intercept means y value 0, right? So 1 over 0 will be reciprocal. So 1 over 0 is not defined. It's a very, very large number. So we have a vertical asymptote here. So we say as the function approaches this point, in this case which is 1, as x approaches 1, the function approaches infinitely large value, and that is the definition of a vertical asymptote. So we have a vertical asymptote here, and the equation of vertical asymptote is x equals to 1. Now, what else do we know about reciprocal functions? Reciprocal of a negative thing is always negative. Perfect. So for this half of the line, which is negative, where f of x is less than 0, reciprocal is going to be negative. Second, reciprocal of 1 is 1, so that is invariant. So let's mark that point. Reciprocal of 1 is 1. This is minus 1. So reciprocal of minus 1 is 1, and reciprocal of 1 is 1. So we mark both the points. So these 2 points are common on our function, the linear function, and also on our reciprocal function. Now let's get all other points. So here we have minus 2. So what is reciprocal of minus 2? Minus half. So let's mark a point here. Let's take this point as minus 4. Reciprocal of minus 4 is minus 1 over 4. So let's say this is our list. Well, as we go here, 5 closer and closer. So 1 over 5, which becomes closer and closer to x-axis, correct? So this half of the graph will start from minus 1 and approach 0. Right? I don't want to touch it, so I'm just keeping it slightly away. But you get an idea. As we are approaching, as x is approaching minus infinity, our reciprocal function is approaching 0 from negative side. Do you see that? Now let's look into the points where the linear function is less than minus 1. So let's say here it is half. So reciprocal of half will be minus half, will be minus 2. So we get a point here, right? Let's say this is very close and this is like 1/4, negative 1/4. So reciprocal will be positive 4. So we can join this, and as we go closer and closer to our x-intercept from the negative side, reciprocal is going to be larger and larger towards negative infinity, right? So we can connect that and form this part of the function. It looks like 1 over x. It is and has to be 1 over x transformed 1 unit to right. That is what it is, right? So let's draw similarly the reciprocal function in quadrant 1. This was quadrant 3 for us. So in 1, we see as the line here is 2, reciprocal is half, 3, 1 over 3, 4, 1 over 4. So this part of the graph is approaching 0, but from positive side. And here, since it is half, it will be 2, 1/4, 4, and going towards positive infinity. That is what. So normally you will see that reciprocal of a function looks like 1 over x transformed. Do you see that? Now let's try to do the next one. This is the only exception to this rule, that the reciprocal function looks like 1 over x in parts joined together. Now let's go for reciprocal of this function. What is this function? This is a constant function, and we can write this function as, let me write this function as y equals to 3, right? At every point y is 3 for us, correct? We could have written equation for this also. We know the slope is 1 and y-intercept is minus 1. So we can write this as y equals to x minus 1. Is it okay? X-intercept is minus 1 and the slope is 1. Rise over run. Easy. Now, what is reciprocal of y equals to 3? So, reciprocal of 3 is 1 over 3, right? So at every point we see the value of y is 3. So reciprocal of 3 will be 1 over 3 at every point. This is 1, so we say 1/3, right? Like this. Every point. So basically it's a line. And what's the equation of that line? So the reciprocal of this is 1 over 3. Do you see that? Y equals to 1 over 3. So this line is the reciprocal of the constant function y equals to 3. So you learned here that reciprocal of a function may be linear. In this case it is linear. Will normally be like 1 over x, except for 1, and that is a constant function. So constant function, so let me write this as constant function, right? Remember this part. Reciprocal of constant function is a line itself, right? It is not a curve like 1 over x. So that is what I wanted to teach you here with this video. I hope you get the point. Thank you.